Hello everyone, this is Mahesh Patil. Today I am going to explain you the topic of grid connected solar rooftop system. So let's begin. Uh, to begin with, we must know about Indian power sector, right? So India is one of in India, power is one of the key infrastructure for growth in industry and economy, right? This everyone knows, and Indian economy has kind of expanded very exponentially in last few years. It was having kind of annual average rate of growth about 7%. Though there were some patches where the growth was down, but all in all the growth was kind of positive and has increased around above 7% per annum, placing India amongst the top 5 countries, or you can say top 5 fastest growing nations in the world. India has kind of 308 gigawatt of installed capacity up to November 2016. India power system is among the largest in the world, but one of the you can say flaws in Indian power sector is that it has less per capita consumption of electricity, that is around one fourth of world average. Also, around 55 million households which are estimated not connected to national grid. So this is one of the concerns for Indian government, and for this kind of things Indian government has taken some kind of steps which are in line with the solar power system growth. Now Indian power sector or Indian power system needs almost a quadruple in size by year 2040 to catch up and keep pace with electricity demand. So how this demand rises? This demand rises with the rising income. So as the income rises, the demand for new connection to the grid rises. Increase of this is around 5% per year, with average solar isolation of 4 to 7 kilowatt hour per meter. This isolation means the radiations coming to the earth. Obviously, India has 300 sunny days in a year, so this puts India in a great position. So India has great potential for harnessing this solar power. Government of India wants a growing share of country's electricity generation from its renewable energy sources. As we all know, focus on renewable energy has increased in recent years. In its NDCs, India aims to increase its share of installed capacity of electric power from non-fossil fuel based energy resources. That means the non-renewable energy resources up to 40% by year 2030. With India setting the ambitious target of 175 gigawatt by year 2022, renewable power is renewable power. This sector is now kind of poised for contemplate, means it is ready for kind of very great rise, right? So as a part of clean climate commitments, these are kind of commitments made globally by the big leaders of the world at kind of forums. So one of this kind of protocol is Kyoto protocol, where all the countries committed for reducing the pollution, right? So this kind of commitments are there, and India plans to install 40 gigawatt of PV rooftop solar system by 2022 with market potential of 124 gigawatt. Around 506 megawatt of rooftop solar has been installed already by December 2016, and this number is growing at kind of very fast rate. Now coming to grid connected rooftop system, as everyone is ready for you can say uh, for kind of installing rooftop connections. Everyone knows what is the rooftop connection, but we'll go in brief and some details about this rooftop solar system we'll discuss here. In grid connected rooftop or small SPV systems, the DC power generated from solar panel is converted to AC power by using power conditioners, right? And it is fed to the grid about 33 kV to 11 kV. So this is kind of you can say commercial type of installations which are there, right? uh, mm, these are three phase connection, and some in some cases the if the power capacity is low, then 440 and 220 residential connections of three phase and single phase lines are also there, right? So it depends on kind of what kind of connections are there, and the technical and legal requirements are there, and according to that the connection is done. This system generate power during the day, right? And which is utilized by powering captive loads and fed excess power to the grid. That means when the sun is there in daytime, the power is generated, that is used, and whatever remains, if the power is more generated more than required, then it is fed to the grid. So the grid is connected. If you are electrical engineer, so you can simply know that it may be connected to 220 or 440 volts, or if it's commercial kind of big connection, then it is at 33 kV and 11 kV line where it is connected. In case when the power generator is not sufficient, the captive loads are served by drawing power from the grid. When the obviously the connection is kind of made that when the power generated by solar PV is more than required, it is fed to the grid, and when the power required is more, but solar generation is less, then in that case the power is taken from the grid. So that is you can say two-way kind of thing. The concept of rooftop solar is based on scale of PV plant rather than the fact whether it is situated roof terrace or not. Hence the definition of rooftop system is also sorry, also includes small plants on the ground. So you might have understood this sentence that it is not necessary that solar rooftop system is installed at roof. It can be on the ground also. It is more on the size kind of thing, right? So kilowatt, how much kilowatt is there, that is considered. You can see here one diagram for this grid connected rooftop system. Here you can simply see that solar is generated by solar sun, right? Then it is given to the solar panels installed on rooftop or maybe on the ground, small size, and then there is a solar inverter, because we need kind of 230 volt AC. So for AC, converting AC, we need inverters or solar converters. This also has DC conversion installed inside. So that is because these solar radiations are kind of variable in nature. So to make it constant, there are some DC converters also. Then it is fed to a connection, you can say point of common coupling, where the grid is connected, right? And where house is also connected. So at this point you get a meter that is called as a net meter. The energy meter normally we call, but now when you connect it to a solar system, then that is called as net meter. Then the appliances obviously are connected, and same way the utility grid is also connected at this point. So whenever the solar is available, solar energy is available in enough quantity, you can give directly through this system to your load. And if the generated energy is more, then some of the power is fed to grid also. In case when sun is not available, obviously in night condition, or maybe low sun is available, which is less as per requirement of home appliances, in that case power is fetched from grid and then sent to the appliances or household use, or you can say the use of electricity, but not reversed to the solar panels, right? So it's only the utility power is only used here in house, right? Then we'll see in brief what are the benefits from the grid connected rooftop solar system. So some of the points I have mentioned here: utilization of available vacant roof space, as the roof is kind of uh, negligible use, you can say. There are some uses of this your roof space, but it is kind of negligible. It is not 24/7 used. So if you put a plant, then the rooftop can be used but 24/7. Then low generation period, uh, I will correct here. 24/7 means the solar panels are there, but this will generate the electricity as and when the sun is available, right? So second point is low gestation period, means you can install it very quickly, right? And then lower transmission and distribution losses, because the system is installed at your rooftop at the point of use, so transmission and distribution is not needed in big way, so losses are improved. Then involvement improvement in the tail end grid voltages and reduction of system congestion. This is kind of technical thing, that the voltage when is transferred from generating plants to the point of use, there is a drop in voltage, right? Reduction also there is reduction in voltage also there. So if the system is installed at right point of use, so obviously distribution losses and transmission losses are not there, so voltage drop kind of things do not happen normally in this kind of system. Also the congestion reduction of system congestion is also is a great point. Then loss mitigation by utilization of distribution network as a source of storage through net metering, right? So you can mitigate the losses, right? In the distribution network, you can say the pelfer or tempering of meter kind of things may be controlled, and also the losses like the tapping of lines also can be controlled. So losses minimization basically is the thing. Long-term energy and ecological security by reduction in carbon emission. So obviously, as we are using solar PV, it's a renewable energy source. It will give you kind of clean energy, so less amount of coal is burned, and this will give rise for clean environment, right? So carbon emissions are considerably lowered. Then abatement of about 60 million tons of CO2 per year over its life cycle. So if you install the solar system, so solar PV system on your rooftop, so this is kind of the thing which is great, that 60 million tons of CO2 per year that solar PV system kind of will try to reduce. Better management of daytime peak loads by discom utility, and that means where daytime peak comes in, power usage is more at peak in daytime, that time you can use the solar power. So this can be managed very easily by with the help of solar PV and the discom power, right? So the load actually is reduced by using solar PV, so that discoms are less stretched. Then meeting of the renewable purchase obligations, that is RPOs, of obligated entities which are targeted about 8% of electricity consumption. So these renewable purchase obligations are actually targeted about 8%. So this can be achieved by this by rooftop installation of renewable energy solar PV system. Also minimal technical losses, as power consumption and generations are co-located, means the losses, as we have already discussed, because of point of generation is at the point of consumption, so obviously technical losses are less. Sorry. Then types of metering arrangements. Obviously, we installed a solar PV system at our home. It needs a legal metering system. It is called as net metering system, right? So it will give you kind of idea about how much is the electricity generated and how much is the electricity conveyed, right? So the total calculation will be based on this net metering arrangements, and these net metering arrangements are done through the discoms. The way how the electricity is billed uh, is kind of done by this net metering system, right? Now we go for net metering. Now the net metering system are primarily aimed to provide opportunity for consumers to offset their electricity bills, wherein single meter records both important conventional energy from distribution system and export of solar energy into distribution grid. Thus, net metering allows the final user to credit produce energy in the grid and also promoted as preferred option. Right. So what this means is when you install a net meter, it will give you the total calculation based on how much energy you generated and exported, if you exported, and how much energy you had taken from discoms. So this will provide you actual calculation based on the how much exact amount of bill you will be paying or discoms will be calculating. So you can see here, when you install a rooftop system, obviously appliances and the load will be there. The net meter here will be a bi-directional energy meter, right? So it will calculate the energy from and grid and also from the solar system, right? So metering gross metering systems are aimed to rooftop owners or third party investors who like to sell their energy to discom using roofs owned by them or another party. So if anyone wants to sell the energy by discount, so the gross metering is used. It is also known as feed-in meter, wherein all the energy is generated from the system exposed to grid, and it's separately recorded through different feed-in meters. So obviously where there are different feed-in meters where the energy is recorded. Then the developer exports the solar energy to utility at a predetermined feed-in tariff. So that is FIT fit. You can say so there is a tariff which is decided in between two parties, the discoms and the person who is generating the solar power. Then it is approved by the regulator, and these rates are then used. And the third party investor or RESCO developers enter into a long term power purchase agreement, that is PPA. So whenever you will install a system of rooftop for gross metering, there will be a kind of, you can say, agreement which will be made on a kind of government stamp papers by paying stamp duties, and that legal agreement will be between the third party or the owner and between the power utility, that is discom. So this agreement will be called as PPA, power purchase agreement. So in this there will be different laws which will be mentioned, and these rules will be followed by both the power discom and the consumer also. Then you can see here gross metering, where the solar is installed on the rooftop of you can say a power factory or a commercial building, or maybe on even a house, and that is not in bi-direction. You can say that is not a kind of system which is there for only single use. This can be used for selling electricity, right? So there are two cases basically to understand this. One, in first case, you exchange power only for the units you consumed, and that is calculated. No, there is no calculation of selling the power, right? And in the second case, you have an agreement wherein you can get actual money by selling the power, right? So there are two business models in India for this kind of thing, rooftop solar PV system. One is capex and another is resco. So the capital expenditure are provided by the rooftop owner in capex, and capital expenditure are provided by third party in resco, right? So these two systems are normally used in India as a legal agreement, right? So in capex model, you can see the rooftop system is there, right? And it's most commonly used for business models. In this model, consumer purchases the solar systems and making 100% of the payment upfront, or financing the system often through a bank, right? So it is a capex model. And then second model is a resco model. Under resco model, resco developer finances, installs, operates and maintains the rooftop power plant, right? Then developer signs an agreement with the rooftop owner, a person. This will be kind of third person who will be installing. Then rooftop owners may consume the electricity generated, which they have to pay pre-decided tariff to resco developer on the monthly basis for the tenure of the agreement, right? Based on the consumption choice and requirement, the model is further divided into two types, that is rooftop leasing and power purchase agreement. So this may seem like a rooftop leasing, or you can say leasing system, but there are two types of or two ways by which this can be done, right? The resco thing, either you can use rooftop leasing or you can go through PPA, power purchase agreement. So you can see here the solar power is installed, or you can say solar PV panels are installed in a college building of at Chandigarh. It's kind of a 50 kilowatt peak power system. So this is it for a simple understanding of solar PV system, which is grid connected. So stay connected for more videos. Thank you. Here we'll end our presentation. Thank you.